This is lesson 9-8, systems of linear and quadratic functions. A quadratic linear system is a system of equations, one of which is quadratic and the other one is linear. There are three possibilities to this system. They can intersect not at all, with meaning no solutions. They can intersect once, meaning the one solution or the line is tangent to the curve, or it can intersect twice through the parabola. So you can have zero solutions, one solution, or two solutions. To solve graphically, the first thing you want to do is graph the quadratic equation. Typically, that's the harder one to graph. Then you can graph the linear equation. Find the spots where the equations intersect, and you should always check by plugging the values back into both equations. Here's an example. Solve the system graphically. Pause the video at this point to give yourself a chance to do the work on your own. Let's graph the parabola first. I'll find my axis of symmetry. Remember that x equals negative b over 2a for your axis of symmetry. So in this case for me, and I'm going to do this graph in blue, x equals negative 4 over 2 times 1, which is 2. So x is equal to negative 2. I'm going to find my vertex point at this point. I'm going to plug in negative 2 to the function. And I get, let's see, with 4, negative 8. So I have negative 2 squared, which is 4. 4 times negative 2 is negative 8. So 4 plus negative 8 is negative 4. Plus 1 is negative 3. So I have 1 point of negative 2 and negative 3. So I'll graph that point, negative 2, negative 3. At this point, I'll find 2 points that are easy for me. So let's see, if I plug in negative 1, I have negative 1 squared, which is 1, plus a negative 4, which is negative 3, plus 2, which is plus 1, which is negative 2. So I have a point of negative 1, 2. By the way, I'm doing all of this work in my calculator to plug in the values. You certainly could also use a graphing calculator if you have it available to you. If I plug in 0, I get 1. And now I'll reflect it over my axis of symmetry, which is x equals to negative 2. So in this case, I have this point here, and I have this point here. And sometimes, just for reference, I'll do 7 points, because I always want to make sure that I have a nice clean graph when I'm graphing two functions at the same time. So I'll probably do another one with 1 here. When I plug 1 in, I get 6. So I'll do that one there, and I'll reflect it over the line. And we'll get 1 there. And so I'll do my best here to do a good job with my curve. And of course, as always, you're labeling your functions. So y equals x squared plus 4x plus 1. My line I'll do in red. Reminder of how we graph lines. We use the slope-intercept form. My m in this case is 2 over 1, and my b is equal to a positive 1. So I'm going to start at 1 on the y-axis. Ooh, there's 1. Up 2 and over 1, all the way through the graph. Now, absolutely no excuse here for not using a ruler. Now, unfortunately, on the computer, I can't use one. So I'll do my absolute best to be as straight as possible. You can see how well this is going for me. Oops. Sorry about that. very hard to draw with a mouse, I'll tell you that much. Have my arrowheads here. Again, and there's the perfect reason right there why you should be using a ruler. That's just deplorable on my part. But again, very difficult when you're on the computer doing this with a mouse. Label my graph as y equals 2x plus 1. And my 2 points of intersection I'll put in green here. I have this one here and this one here. This point here, I always label them, is -2, -3. And this point here is 0, 1. Now at this point you should be going back into both of your equations and plugging the values back into both equations for both points to make sure that it's clean. We also can solve quadratic linear systems algebraically. We have the two methods that we learned with linear systems. We have elimination and we have substitution. To solve algebraically by elimination, the first thing you want to do is put your quadratic equation into standard form, which is y equals ax squared plus bx plus c. Put your linear function into slope-intercept form, y equals mx plus b. Next, subtract your equations. Solve for x. And plug in your values for x to give values of y. Here's a guided example on the right. You'll notice that they're already in quadratic function is in standard form, and the linear function is in slope-intercept form. Notice why we're doing that. We have y alone on the left side of both of those functions. We want that when we subtract. So now we're going to subtract. And that gives me y minus y, which is 0. That's the key thing. We've eliminated y. So now I have x squared negative 6x minus x is a negative 7x, and 5 minus a negative 1 gives me a positive 6. Careful with those signs as you subtract the equations. Now I'm going to factor. Factors of 6 that add up to negative 7 would be negative 6 and negative 1. So I have x minus 6 and x minus 1. I will use the zero product property, split set solve technique. And I will solve for both here. So now I have two values for x. I need to go back and get values of y. My personal recommendation to you would be to use the linear function since it is easier. Y equals 6 minus 1. So y equals 5. Now I do need to group these together, which I'm going to do here in orange. When the x value is 6, the y value is 5. For the other one, I have y equals 1 minus 1. So y equals 0, and I do need to group those together. So my value there is 1, 0. So when x is 6, y is 5, and when x is 1, y is 0. And those are my two solutions to the system. Solving by substitution starts the exact same way. You'll still put them into standard form and slope-intercept form respectively. But then you will set both equations equal to one another. You'll be able to do that because they are both y equals. You'll solve for x, and then again plug in the values for x to get the values for y. You'll notice I'll be using the same exact two functions. I'll set them equal to each other. And then we will go to work. Minus x and plus 1 minus x plus 1. X squared minus 7x plus 6 equals 0. You'll notice that I'll be doing the exact same thing that I just did on the last slide. Factors of 6 that add up to negative 7 are negative 6 and negative 1. This thus proving that it doesn't matter which method you use, you will get the same answer, provided that, of course, you are doing it correctly. And then again, you would go back in and plug in. Again, I recommend using the linear function. As you can see, that both procedures are relatively the same. Here's some examples for you to try. Do the left side by substitution, do the right side by elimination. Pause the video at this point to give yourself a chance to do them on your own. Let's take a look at the substitution side. So the first thing I need to do is add 1 here so that I get y equals 2x plus 1. That puts it in slope-intercept form for me. Then I can set them equal to each other and subtract 2x and subtract 1. And I get 0 equal to x squared minus 6x plus 8. I'll then factor. Factors of positive 8 that add up to negative 6 would be negative 4 and negative 2. Zero product property, split set solve. And we have x equal to 4 and x equal to 2. Plug them back into the original linear function. So y minus 1 equals 2 times 4, which is 8. And then adding 1 to both sides, so y equals 9. So my point here is 4, 9. And here I have y minus 1 equals 2 times 2, which is 4. Adding 1 to both sides gives me y equal to 5. So this point is 2, 5. For the elimination side, I need to move the x squared over and then divide by negative 1. That gives me negative 5 minus x squared equals y. And I could always switch that around to get y equal to negative x squared minus 5. Now I can subtract these two equations. So 0 minus x squared minus a negative x squared should give me an x squared. 3x minus nothing is 3x. And -1 minus a -5 gives me a +4. So this one isn't too clean. I do not have factors of +4 that will add up to +3. I'm going to do completing the square for this one. So I'm going to subtract 4 from both sides. So now I have -4 equals x squared plus 3x. Dividing 3 by 2 would give me 1.5. And then squaring 1.5 gives me 2.25. So now I have -4 plus 2.25 equals x squared plus 3x plus 2.25. So now I have negative 1.75 equals x plus 1.5 quantity squared. Square rooting those tells me right away that because I'm square rooting, I am now going to have no real solutions because you cannot square root a negative number. So your answer for this one is no real solutions. If you have any issues with this particular lesson, please make sure you're consulting your teacher in class.